The core of this talk is based on a paper I published in December of 2013 in the Communications of the ACM. It's called Data Science and Prediction. It's available on the internet. And I'm just taking sort of the core ideas from that paper and embellishing them with some additional insights I've had since then. So the examples I'll use are from finance, from healthcare, and sports, and maybe a little bit from social media. But those are the core areas. I've been working for a long time in finance. My foray into this world of data, and specifically machine learning and data, really happened in 1990. I just gotten tenure then at NYU, and I was wondering what to do with the rest of my life. I had had enough of working in sort of knowledge-based systems and expert systems, which was what artificial intelligence was about at that time. And I was on the program committee of this conference on AI applications, and this was in Boston. I was walking back to the hotel with sort of an older friend and mentor of mine called Dave Waltz, who was the chief scientist at a company called Thinking Machines. And he said to me, he said, databases are about to happen. And I said, what do you mean they're about to happen? Databases have been around for 20 years. He says, no, I mean, data is about to become real. It's going to go from sort of the dungeons to widespread availability of data. So I came back and I decided that was a cool area to, that the future was probably going to be one where data were available and we could actually use data to generate insights as opposed to trying to generate everything based on theory and decree the world the way it should be, right? So maybe there was some value to actually looking at data. And that was also pre-internet, right? So the internet hadn't happened then. So my visions were quite limited at the time to corporate data. And I came back and got in touch with some people I knew at AC Nielsen, the media company, and they were tracking 50,000 households all over the US. And every time you bought something, you came back home and you scanned it into a database and off it went. And so they gave me this database of data over a couple of years from 50,000 households, which at that time was big data. These days would be medium data. And they said, see if you can find something interesting. And I said, what does that mean? I said, well, you define it. So I cranked through this data, and several months later, they came over to Stern, which wasn't Stern at the time. And they said, so, did you find anything? I said, yeah, there's lots of things in the data, but I have no idea why these exist or whether they make any sense at all. And they said, okay, let's go down the list. And so the first one was, women over 40 in the Northeast do a lot of shopping on Thursdays. And the guy said, oh yeah, that's coupon day. What else did you find? And I was just so excited that the machine had found this pattern in the data that I hadn't really told it to find, right? I hadn't actually formulated the problem in that way. All I really gave it was some idea as to, that interestingness would be based on, distributions that were different from the unconditional distribution. And that's sort of at the heart of big data and machine learning is that in the old days of small data, we sort of focused on the average effect of something. And suddenly with a whole bunch of data, you could actually probe the distribution in more subtle ways. And so that was kind of the beginning for me. I sort of became a believer, not just in the power of these machine learning methods. And at that time, I was playing around with something called genetic algorithms, which are based on sort of models of sort of evolution. And they work iteratively at finding patterns in data. And the basic idea, imagined at a very high level, is that you have a database and you have a population of queries that you keep throwing at the database. And the idea is that instead of asking the question that says, that you issue a query and the data comes back, right? You sort of turn the problem around on its head and say, the machine basically says, if only you knew what question to ask me, I'd show you something really interesting in the data, right? And that was, to me, the key insight. And the genetic algorithm was essentially a bunch of SQL queries, for those of you that are familiar with databases. And so the mechanism was that I would generate a bunch of queries randomly. They would go into the database, the data would come back. There was a little sort of statistical module that did some analytics on top of that, and essentially looked at whether the conditional distribution was different from the unconditional one. If it was, that's interesting, and would flag it, right? So that was the basic idea behind the method, which sort of made me a believer, and that's at the essence of both the intersection of data and machine learning. So I've spent way too much time on the title slide, so let me just speed things up a little. So my agenda here is, I'll just briefly discuss the size of the market for big data, what's unique, and I've already given you a flavor of what's unique, so I'll go through that a little faster. What gives big data real value, and where's the opportunity, right? So this is a real high-level view, right? So the market for big data is expected to double in the next 3 years, from roughly 28 to $50 billion, and this is the distribution in terms of, so this is 2013, services, hardware, software, so you can see about 2/3 of it is in services and software, and this is the breakdown. So professional services around data are expected to be like the largest piece of the pie, which makes a lot of sense, right? Because there's a lot of data out there, but there's a lot of uncertainty as to how do you really go about exploiting it, and should you even set up the internal capability to do it, or how much can you outsource and get the market to do for you? And so the expectation is that the professional services part of this is actually going to be the bulk of it, and then you can look at the rest of it, which is not particularly surprising. So what's unique about big data? And I want to give you a flavor for this, but it's really a whole new way of observing and learning things. And the key is, I put this in parentheses, with minimal pre-programming, right? That's the essence of it. That is, you shouldn't really impose a lot of work in looking for stuff, right? That the computer should really do that for you. And what's unique and different about this whole new area is that you have really diverse sources, types, and structuredness of data, right? And what I mean by that is you've got text, you've got numbers, you've got tag text. So there's different sources of structuredness in the data, and that's what makes it interesting and challenging. And so it's granular, right? So it tends to be the frequencies at which you're observing things tend to be much more granular than they've been in the past. And the third thing is the analytics, which is what brings it all to life, is the ability to ask the right questions of the data as quickly as possible. Now, one of the things I mentioned was that I've been working in finance. Sports has been another area that's fascinating. I'm working with one of the NBA teams, basketball teams, and looking at big data in sports. And the as quickly as possible is really key, right? Because you can't, it helps you can generate these insights quickly so you can act on them, right? You don't have a lot of time, you don't have a lot of manpower, so the speed with which you get insights is actually pretty critical. And from an epistemological view of things, the right questions are one whose answers have predictive power, not just explanatory power. And that's one thing I really want to stress, and it was one of the things I stressed in my paper, is that it's prediction, ultimately, that's the real epistemic criterion in what constitutes new knowledge, right? And that requires a completely different orientation towards modeling than explanatory modeling does. Where you just keep adding variables and you keep getting to the R² keeps going up, and you explain more and more of the phenomenon. But when you apply it in the future, somehow it just doesn't work, right? It has very little predictive power. And when you focus on prediction, that is what the onus is to look at, to make predictions about, to make estimates, or to come with estimates about things that have not been observed so far. What happens generally is that your orientation is viewed towards simplicity, right? So Occam's razor becomes much more important than it does with explanatory modeling, where you just sort of keep adding variables to explain, right? So prediction requires a different kind of mindset, and simplicity becomes really key, because ultimately, and this is, accords with my experience, especially in finance, which is like squeezing blood from a stone, right? That's kind of, the problem is about as noisy as you get, right? And complexity just kills you. And that's been my experience. Ruben mentioned that I started a hedge fund, and one of the things I've learned over the years is that it just pays to keep things simple, right? Simple just seems to work better. And for those of you sort of who have experience in the area and have done this kind of modeling and back testing and things like that, one of the things that always haunts fund managers is, how come reality never resembles the back test, right? And I've been at conferences, with colleagues, with other portfolio managers, where the question, strangely enough, has been, so how much of your theoretical performance do you achieve in practice, right? Which, when you think of it, is such a bizarre question to ask, right? How much of your theoretical do you actually realize in practice, right? I mean, right away that tells you that there's something wonky about the way you model stuff if your question is, how much do you realize, right? Because at the end of the day, those two things, if you've done your modeling correctly, whatever that means, they should resemble each other, right? So I've actually moved towards a situation or a state of affairs now when I build a predictive model, if it looks too good, I throw it away, because it just I couldn't possibly achieve that in practice, right? So in a sense, I tell people that I have a great relationship with my kids because I set their expectations so low. So my expectations are low of what I will be able to achieve. So when I model something, if the numbers look like they're sort of middling to mildly interesting, to me that's interesting, because that's probably what I'm likely to achieve in practice. So here's a question of asking the wrong question, right? So it's like, and I took this from, there's a character in the social media called the Fat Jew. And he publishes all these bizarre sort of graphics. So I thought this was a great example of like asking the wrong question, right? Via surveys, right? So you can draw whatever conclusions you want from that. But what's the right kind of question, right? So examples of the right kinds of questions in healthcare is like, who's likely to get sick, right? Because the statistics on this are pretty staggering in the US, right? Like roughly something like 25% of the healthcare budget goes into treating like 2% of the people, something like that. And the largest number of dollars are spent in prolonging people's lives by 6 months, right? Something like that. So, and clearly if the objective is to just prolong life at all costs, then the system's going to go bankrupt, right? So the who is likely to get sick is really interesting because it has implications for prevention and planning. What's the best treatment is another really interesting question. I read a statistic somewhere that 90% of physicians' decisions are not based on knowledge gleaned from clinical trials. They're just based on their best guess or gut feel about what's likely to work for a person, right? Now this, again, is an area where data can have a huge impact, right? Because you're observing all kinds of stuff from the healthcare system. And so there's great value in data in answering this kind of question as well. What's the best treatment? Sports. What kind of players do I hire, right? If you've read or seen Moneyball, right? Should I hire a rock star player, or should I hire a guy that will improve the average performance of my entire team? Again, this is something that is potentially answerable through data, and I'm finding that certainly to be the case in basketball, right? That is, you can have a huge impact through these kinds of decisions as to who to hire, based on what their impact on the team is going to be. What about the strategy for the next opponent, right? So what happens later on in the season is your seasoned players, your older players, have risk of injury, right? So just like finance, you wonder about how much risk do I take? Same kind of problem shows up in sports. How much risk do I take? So if I were to give you the following sports, basketball, soccer, hockey, ice hockey that is, football, baseball, how would you order them in terms of the role skill plays versus luck plays? Right? Now there's a correct answer to this question, by the way, and I often I often pose this when I teach a course in big data analytics, is because everyone identifies with sports. I say, how would you order them, right? What does your intuition tell you, right? So clearly, if I look at something like chess, right? Now, I don't care how good you are at chess, right? Even on your best day, you're not going to beat Kasparov. No, it's not going to happen, right? Kasparov is just too skilled for any one of us to beat him, even on the best day, right? Whereas if you and I go to play roulette, well, then it's a complete crapshoot, right? Half the time you'll win, half the time I'll win, right? So there's this spectrum, right? There's this continuum of like signal versus noise. And I look at finances in this way as well, right? So what I like to do is I like to quantify the amount of signal or noise in a financial problem as well. And it turns out this is a fruitful way of looking at these kinds of problems. So let me come back to this question that I raised. I gave you those 5 sports. Does anyone have any information? So it was football, baseball, hockey, soccer, and basketball. How would you rank them in terms of skill versus luck? Which one would you say has the most skill? Which one would you say has the most luck?
Basketball skill.
Basketball skill, does anyone agree with that?
Ice hockey.
Basketball luck.
Basketball luck.
And ice hockey more skill.
Ice hockey more skill. What about baseball?
Baseball more skill.
Baseball more skill. Football, American football, by the way. What about soccer?
Skill.
Skill? Okay, so the answer is basketball has the highest level of skill, and football has the highest level of luck. Now, if you look at if you really sort of think about the problem, you'll see why, right? There's several reasons for it. If you look at a basketball game, right, what's the role of random events playing and having an impact on the outcome? Minimal, right? Someone like has an amazing 3-point shot from way outside the perimeter, right? Is that going to have an impact on the outcome of the game? Unlikely, right? Whereas in football, there's fumbles and interceptions and all that kind of stuff, right? And on the best day, the crappiest team can beat the best team, right? Just out of luck, right? Something goes wrong, the quarterback fumbles. Baseball is the same way. You take a swing, it just lands between 3 players. You can get lucky a lot, right? Similarly, in basketball, there are roughly something like 100 possessions per side per game, right? Equal number of possessions, right? It's unrelenting. You're just going up and down the court, right? So it's at the end of the day, baseball is a lot of skill, and luck plays a very small role in outcomes, right? As compared to, let's say, and there are 82 games per season, by the way, right? So the N is relatively large, right? Each team plays 82 games versus football, where there's 16 games, right? Baseball, there's more games. Now, there's another consideration that comes in here. Now, soccer is really interesting, right? If you follow soccer the way I do, because my son is a soccer fanatic, he's a Manchester United fan, I think we'd all agree that the level of skill in soccer has really gone up in the last 10 years, right? I mean, it seems like the ball is just glued to these guys' feet, right? The amount of control is just amazing. And I was actually, it's funny, I was reciting a paragraph from the Satanic Verses to my wife on the plane. We just came from Thailand. And I was telling her about this paragraph where Rushdie imagines London turning into a tropical city, right? And he says, what would be the advantages and disadvantages? And among the advantages, he lists better ball control among soccer players, right? And this is like an 80s thing, right? Where the South Americans just had ball controls and the Europeans didn't, right? That's all changed now, right? But if you read the Satanic Verses when it came out, it was really hilarious to read that, better ball control among soccer players. But what I was going to say is that in soccer, if you look at the skill level across the league, it's gone up like crazy, right? So in a sense, what really matters is not just the average skill level, but it's the differential in skill level, right? If everyone has the same skill level, randomness will play more of a role in outcomes, right? Than if skills are differentiated, right? It makes complete sense when you think about it that way. Another example is targeting, who to target products and services to, how much should I pay to advertise. So advertising is becoming basically an exchange traded kind of a situation now, right? you open your browser, an ad shows up. You know, how does all that happen? It's magical. Essentially, there's an auction going on behind the scenes. You know, different players are bidding for how much to show you, and the bidder of the auction wins, and boom, you get a ad shown to you in 30 milliseconds, right? All of that stuff is happening behind the scenes. It's all happening based on data, right? It's all, and the data that is being based on is your browsing patterns, right? So people are recording, which websites you go to. So Ruben and I go to the same kinds of places. We have the same, we will likely to have the same brand preferences. All that kind of stuff is used to decide, whether it's worth, how much to bid to show an ad, to you, right? So that's this set of problems. So I'll just, I've been talking about the right questions, but I've already given you a flavor of what the right kinds of questions are. So in sports, the right kinds of questions, for example, are, what does it mean to break down a defense effectively? Because presumably, if a team is successful in breaking down the defense of another team, chances are it's probably winning will go up, right? How do you really tell that from the data? Whether you're breaking down the defense effectively or not. Turns out that you actually can tell that from the data, right? So for example, if you look at how many shots are taken from within the paint, or whether shots are distributed evenly, or whether they're always taken from a certain point of the court, all that actually tells you how effective you are at breaking the defense down. So here's an example I've taken from healthcare, where I did a project involving looking at people who develop diabetes. It's a big problem these days. Sample size here was, several tens of thousands of observations. This was a data set I got from an insurer. 70, 80 million observations. Every point of contact with the healthcare system was a data point. I ended up looking at about 70,000 people who had developed diabetes, and the question was, which type, under what conditions do people develop complications? And this is a graphical depiction of the problem. So essentially what I did was I took all the data and I created one record per person, right? So you can look at each of these colored chiclets as being, let's say, a treatment or a drug or something like that, and time runs left to right, right? So this is what I call the clean period, that is before people are diagnosed. Right? This is, the red line is bad stuff happens, you're diagnosed with diabetes, and this is an outcome period in terms of costs and complications, right? Those are the two things you really care about. That is, what are my future costs expected to be for this person, and is this person likely to develop complications, because complications tend to be nasty, right, to deal with. And it's like, what's the right question here? When you look at this problem, it's just like a massively complex, unstructured kind of problem, right? Is it, are complications associated with the yellow meds? Well, that's a question. You can certainly do the counts and answer that. Or is it the gray meds? Or is it the yellows in the absence of the blues? Or is it more than 3 yellows and 3 blues, right? You get the idea, right? The list just goes on and on. It's a huge potential set of questions you can ask, and this is where the computer can actually help you in surfacing or asking the right kinds of questions. Or does it have to do with lifestyle choices? Were all these people just couch potatoes who decided to go for drugs versus people who decided, I'm just going to do exercise. I'm going to try other alternatives, and maybe those people are not represented in this population adequately, right? So that's another question: is my observational data a good representation of reality, or is it somehow biased? Okay? And that's a real problem with observational data and situations where you really can't do controlled experiments.
What about heredity as a factor here?
Could be, right. So those are certainly factors, but that's an easier one to consider, right? Because if it runs in your family, well, that can be an indicator, right? I mean, that can be another colored chiclet, right? So if everyone has this problem in their heredity, then actually it's equivalent to a chiclet that's just fixed, right? It doesn't change in time. Just to kind of switch gears a little bit, so I took this from a couple of surveys, and this is presumably the anticipated opportunity in around big data is a lot of it is expected to go around sort of the customer experience side of things, right? And this can be, and this doesn't have to be like customer in the sense of businesses. It can be government kinds of things. It can be national health programs, right? So it's kind of the end user experience is projected to be a big area of growth. Operational efficiency, yeah, but it sort of bottoms out. Targeting and marketing, again, it sort of flattens out. Real-time analysis and decision making, this can be in transportation systems, urban systems, stuff like that, where we're already beginning to see data play a role. Which route should I take to get from A to B? Right? There's sort of much more real-time decision making being enabled because of the availability of big data. On this side of the picture, this is from a survey on leaders and laggards. Right? What distinguishes leaders from laggards in the big data space? And the two important or interesting charts are that leaders tend to upgrade the entire IT stack aggressively, right, as opposed to just tools, right? So that's one area. And the other thing is they don't wait around and see. And so there's no wait and see. Right? They just tend to move and start making decisions, much more quickly than people say, let's wait and see. Right? So those are the two things that really stood out that sort of make sense. So just in terms of my own research, I've done a fair amount of research in financial markets around numerical data. I've been doing more stuff around unstructured data, like news, making sense of news, sentiment, and so on, which is interesting and challenging to deal with. Here is a really quick overview. This is a program that I've been running that trades only the most liquid futures contracts in the world. Right? So it's a highly scalable kind of a program. One of the realities about financial markets is that as your holding period shrinks, the capacity or the amount of capital you can deploy tends to go down really rapidly. I did a lot of high frequency trading in the early part of the decade. The amount of capital that you could really deploy was really small because of impact kinds of issues. So this is at the complete other end of the spectrum. These are futures markets, position trading, where you hold for more than one day. And this is a completely systematic, data-driven program along the lines that I was talking about, which is that the machine looks at the data, learns, trades. At the end of every period, which in my case is a year, it retrains, rinse and repeat, trades for the next year. Right? So it's a completely systematic trading program, and that's the equity graph. This bottom line, there's a cone plot, which is a really interesting way of looking at the world, which I got from, which an investor actually asked me for. This is the performance, best, average, worst case. So essentially this says that over any 24-month period, if you have a 2-year investment horizon, you're always positive. At least historically that's been the case. So that's interesting for investors. The scale here is somewhat irrelevant because I can make it look anything I want based on the amount of leverage.
And this is numerical or unstructured? What's the raw material
The raw
system
material
is
is
using?
purely prices.
Okay, so this is just historical prices feeding into a trade.
It's historical prices feeding into a learning machine that creates a model that then trades.
And
So
the trades are like 1 day holding period. So this is not intensive intraday.
This is not intensive intraday. The intraday stuff, the performance is many times better than this, but the capacity, of course, is very limited. Right? So this is like very high capacity. By high capacity, I mean of the order of 1 to 2 billion in terms of capacity. Right? So this is a high capacity program. At the moment, it has about 140 million under management. Mostly, all institutional money, some pension fund money. But the nice thing about it is it's scalable. Right? So the price you pay for scalability is low Sharpe ratio.
Okay, so we economists believe that with standard linear models, this can't be done.
I know, yeah.
So what's the difference? Is it that there is non-linearities in the data that you're able to pick up?
Yes.
Okay.
So I guess the short answer I'll give you is that I believe that there's really no alpha in this, right? So if you look at high frequency stuff, I believe that there's real alpha in there, that a program like that really picks up on obvious kinds of inefficiencies. They're glaring inefficiencies in the market that can pick up on, but the capacity is limited. A program like this is taking risk. So whereas alpha associated with like basically about as riskless as you can get. Right? Whereas this is actually taking risk. It's taking it's really exhibiting what I call exotic beta. There's no real alpha here, but there are interesting betas that it's picking up on that tend to be repetitive, over reasonable periods of time. So in the short periods of time, you can get shocks, or you just are unlucky, or stuff doesn't work for some period of time. But if you're patient, these things tend to work out.
Okay.
So that's the.
So this is showing like 40% over 5 years, and that's pretty good compared with the S&P 500 over the same period.
Yeah. So, like I said, the scale here is somewhat artificial because this thing is operating at a volatility of about 6%. Right? So the volatility of the S&P is about 24%, right? So this is about a quarter of the volatility of the S&P. So in terms of my risk-adjusted return, it's about 2 or 3 times better than the S&P. Right? So the S&P return is about 0.3, the Sharpe ratio. This is about 0.9. Okay. So on the risk-adjusted basis, it's better. Like I said, I can make the scale look whatever I want by basically adjusting leverage, which is the beauty of this program, right? So it's very capital
So it's a
efficient.
bunch of futures, and
These are futures.
you could choose to layer on S&P 500 futures to bump up the leverage of the overall
So
position.
this trades the S&P futures as well.
Oh, okay.
This trades futures on the S&P 500, the VIX, all of the rates, all of the currencies, and all of the equities.
These are all the biggest liquid.
This is the 40 biggest futures contracts on the planet, right? Across these. It also trades energies and metals, gold, silver, and copper in the energies. Right? So only the most liquid contracts. And this is the benchmark SDTI. So it's outperformed the benchmark reasonably well. The nice thing about, the more attractive thing about this is that it's really tends to be generally uncorrelated to almost anything. So the correlation with the S&P is almost zero. So it's the selling point is that it's a nice add-on to traditional long-only kinds of programs. The other part of my research has been in networks, in media, social, and health. I've described some of this stuff, and currently over the last year or so, I've gotten really heavily engaged in sports, which I find sort of intellectually fascinating, but also is really interesting in the analogies that it makes me aware of between things like sports and finance, and things like signal and noise. So it's been a really interesting sort of foray into sports. And then at a really high level, I'm really interested in the governance of data and analytics in companies, and I write about this in the popular media. Things like what data should you keep and why? What are the risks associated with keeping data? And things like what capabilities to develop in-house versus outsourcing to the market, which are really interesting sort of governance questions for companies. So that's pretty much it. I'll just wrap up and say that I find that this is really a fertile area for research. There's more and more interest around unstructured data and making sense of that automatically, because there's just no way to do this in any other way, right? Because our capacity for analysis is kind of limited. Acquisitions like that of, how many of you have heard of DeepMind? DeepMind is a company that was formed around something called deep learning, right? So what I do is shallow learning, right? It's sort of much more akin to, let's say, what econometricians do, just with a different set of tools and questions and orientation. But this is this whole area of deep learning is kind of fascinating, and this is what DeepMind did, right? So they showed up at this conference and they demonstrated this machine that was given access to a video game, right? It said, okay, here's a video game, here's what the screen looks like, and here's what the controls are. And by the way, there's a score over here, and a high score is a good thing. Go for it. Meaning, learn how to play the game, That's all we're telling you, right? And the machine basically learned to play the game and it can beat any human being at it, right? Without being told anything, right? So it wasn't given anything about the representation of the game. It was just given access to the controls and the screen. That's it, right? And the machine learned how to play the game, right? And Google acquired them a month later. Why? If you really think of it, right? And I teach a course on IT strategy as well, where we discuss sort of competitive advantage and how to sustain competitive advantage and network effects and all that kind of stuff, right? And how Microsoft has network effects because they really got you by the, whatever you want to call it, because if you want to use Word and share files, other people use Word, and there's like strong network effects, right? And Google has no network effects, right? They've got cool tools, right? But do you have any loyalty to Google? Not really, right? If another search engine comes along, you'll go for it, right? What do they have, right? But this is actually, in my mind, a really well thought out strategy by Google to actually acquire the capability to have their systems learn to become better by themselves with no prior programming or not being told what better even means, right? So the machine is able to figure out what better means, right? And better in this case could mean the user likes what they're using, or the user doesn't like what they're seeing, right? Maps becomes better all by itself, tuned to you. Mail applications become better, right? So the assumption here, clearly, that's being made is that this kind of technology has the ability to learn. And I initially earlier in the talk I talked about minimal programming. That's essentially what this is about, right? You're not telling the machine a hell of a lot.
So what's the key idea? How does deep learning work? How is it different from our usual approaches?
So there's several basic tricks that are taken from something called reinforcement learning, which we as humans do sort of almost without thinking about it, right? Or ants do without thinking about it, right? It's something, so ants do reinforcement learning essentially by saying, an ant's walking, you poke it, it freaks out and runs away, right? And it's walking, you poke it, its reaction is a little less extreme. It walks again, you poke it, and it realizes, like, this guy's just like fooling around with me, I'll just keep walking, right? So it learns that this isn't dangerous, right? The other side of it is that it learns that other things are actually good for it, right? So it learns that when red things are coming down, run away from them, and green things are coming down, go eat them, right? So these are different forms of reinforcement learning that deep learning actually makes use of. It turns out that there are also other sort of very simple technical tricks that have gone into developing this capability of deep learning that I don't want to get into right now, but I'm happy to do that offline.
No, but I think it's useful even to talk about the paper, Minsky paper. I mean, I think the problem that was actually solved.
Okay, so let me give you like a few quick sound bites, right? So I've been in artificial intelligence for my entire career from grad school, and I've seen the cycles of hype and bust, right? Several times, right? In the 70s and the 80s, like, there've been these big expectations of artificial intelligence which never really materialized. And I tell people that I actually now I'm completely blown away by what I'm seeing, by the ability I'm seeing, because my expectations were set sort of in my graduate student and my early academic days, and they were set to be reasonably modest, and they've really been exceeded by what I've seen around. In 1969, there was, in the 60s, there was a lot of research going around this area called neural networks, and there were two influential guys from MIT, Minsky and Papert. Minsky was actually an advisor to 2001, the movie. Minsky and Papert wrote this really influential paper called Perceptrons, it was a book called Perceptrons, where they basically argued that you could not train a neural network that had a hidden layer in it. It was only possible to train a network with two layers, input and output. And they showed that this whole input-output architecture could not solve even simple nonlinear programs like an exclusive OR problem, that the machine was incapable of learning the exclusive OR condition. And so this sort of killed research in neural nets for a while until the mid to late 70s, when a grad student from Harvard came up with this algorithm called backprop, which demonstrated that it was actually possible to train a network with one hidden layer. Subsequent to that, there were people who came up with a theorem that said that multi-layered neural nets were equivalent to a single layer, hidden layer net. That there was actually no advantage to having multi-layer neural networks that was equivalent to having a single layer. So a lot of the research really focused on single layer, single hidden layer neural nets. It turns out that there are great advantages to these multi-layer networks now, and that's the technology behind these deep learning kinds of systems. So it turns out that there are actually advantages to having these layers that learn how to figure out what the right features are in the data. And they've been very powerful at solving image recognition and voice recognition kinds of problems. And so all I need to do is take one image of Ruben sitting like this, and I can recognize him in a crowd of 1,000 people from any position. And that's sort of the capability that these deep learning kinds of systems have. I don't need to take a gazillion photographs and train a net. Nor do I need to measure the distance between his eyes, the length of his nose, etc., which is essentially what traditional machine learning is about. The computer actually figures out what the important features are in doing image recognition, and it applies them in recognition kinds of tasks. So in a nutshell, those are the kinds of tricks. There's a few more that have led to this new kinds of capability that you're seeing in companies like DeepMind. And there's a huge amount of interest in it. Several of my colleagues at NYU who work in this area of deep learning have been snatched away by Google or Facebook and all these companies that are using this stuff to do image recognition, voice recognition, etc. So there's a huge interest in this area because it seems to work. So that's pretty much it. And so we're finally entering the area of really smart machines driven by big data and machine learning. And like I said, it's really exceeded my expectations. The kind of capability I'm seeing now, and it's only likely to accelerate. Thank you.
Yeah, thanks, Vasant. Open for questions.
Wasn't the Big Blue chess program an example of artificial intelligence?
It was, but even more interesting than the chess program was the Jeopardy program, right? Now, Jeopardy, by the way, also completely blew my mind. Like, I never thought in my living existence I would see a machine beat the best Jeopardy players, right? Without knowing what the topics were going to be, what the questions were going to be, the nuances involved in the questions, even interpreting the question, right? To me, that was like really mind-boggling that a machine could actually beat humans at Jeopardy, right? And in a way, that really was the first demonstration of a machine passing the Turing test, right? If you would not have been able to tell which is the human and which is the machine, right? So that was a pretty amazing milestone in my mind. And what we're seeing now is IBM is trying to obviously go beyond Jeopardy. They're using the same kind of technology to solve all kinds of problems. It turns out that it's harder than one might imagine, but still, that's really impressive, right? And that also is a capability that's based on not just big data, but essentially every trick in the game. From high performance computing to machine learning to entity extraction from data, etc. So we've essentially thrown every trick in the book at that problem.
Sorry, if you don't mind. I have one more question related to the healthcare sort of information you were sharing. What's the best treatment, for example? I've seen a number of programs that are coming into the market which help doctors with diagnosis and then with suggesting lines of treatment. But I see in India there's extreme reluctance on the part of doctors to have a machine tell them what to do. Have you seen sort of more acceptance in the US?
That's a great question. It's, in my graduate school days, my thesis advisor he had developed the first program in medical diagnosis that covered the entire field of internal medicine. It was called Internist Caduceus. And I used to see doctors come up all the time to the 12th floor of the medical school disagreeing about a case. And they would say, well, let's go ask internist, right? And they would, I'd hear laughter, I'd hear like, wow, never thought about that, right? And oftentimes they would go away still disagreeing about the case. but they were always fascinated by it, but they'd never really use it. And in the US, there's fear of lawsuits and all that kind of stuff. So it's complicated, right? The extent to which you're going to take advice from a machine. On the other hand, I think it's also, this is also sort of a social phenomenon, right? And I think that it's a social one, it's a generational one, right? I would conjecture that over time, people will be more amenable to looking at the data, right? So that system was an expert system, right? It was based on years and years of like culling out knowledge from an expert and coding it into a system, right? If you actually show a physician like bar graphs that say, well, there were 3,000 cases that looked like this, right? And in 1,500 of those, here's the treatment that was applied, and here was the outcome. Here's the treatment that was applied, here's the outcome. You decide, right? I think people would be foolish not to consider information like that in coming up with a differential diagnosis. So the answer is, in a nutshell, is it's complicated, right? And yes, a lot of it is kind of a social, generational kind of phenomenon, right? But I would expect that over time, as there's more data, as there's more observations, right? As we instrument the body better for observation, which is another thing that's happening, right? In the past, the basic risk factors were like body mass index and stuff like that. We weren't really instrumented for observing stuff the way that we're instrumenting ourselves now. As we get more data, better instrumentation, chances are that it's going to be difficult for people to actually avoid looking at the data. Other questions?
Yeah, just want to know, like the commercialization bit, how do you see this use of data, going to smaller firms and used by large number of people? Like search engine, for example, in one point of time would have been used only by very select group of people, right? Because it would have been a niche thing.
Right.
How do you see the commoditization of basically such kind of technologies happening? And the second question was, choosing the right metric and asking the right question is the most difficult thing for firms. Like even with the video game, you have to tell the computer that you have to max this score, and then they'll figure things out. But giving the right metric, what needs to be done is where most people struggle. And the last part of the question was that the data was not being used because you said on an average this happens and the probability of X happening will be Y. But for people who are making decisions, they need to make, if the machine can tell them in this situation, if you do this, then the following outcome will come. At an individual level, if you have a predictive behavior, then a large number of people will start depending more on data and machine than they do right now. I just wanted to know if these three will tie up in making it more, people using data a lot more than what they do right now.
So the short answer is yes, but there were there's several sort of the first question. So
how will it become more useful?
Okay, so the way I see that happening is that it's different in different areas. So for example, in sports, right, every game is, so I have the play-by-play data for the entire league for the last 10 years, right? Every play that was made in every game, I have the data, right? And that's been coded up already. There's people sitting courtside coding it up. There's also 6 cameras on the roof recording every game, right? Making sense of that data is extremely difficult, but there's a lot of entrepreneurial activity around that, right? Because if you can actually take those images, the moving images, and calculate things like the average distance traveled by a player, which you actually observe now in sports, right? They tell you like, someone ran 9.1 kilometers during the time they were on the field. Like all that stuff's being calculated, right? There's a lot of activity around making sense of that kind of data, right? A lot of entrepreneurial activity around that. And I'm seeing that in social media stuff as well, right? I mean, not a week goes by, where some guy doesn't approach me and say, hey, I've got this amazing way of like analyzing Twitter data, and look at the stuff I'm able to analyze based on, a gazillion tweets, right? I can extract sentiment, and look, it actually correlates with something else. There's a lot of activity in this whole big data space and making sense of the data, right? A lot of activity.
Asking the right question.
Yeah, no, so, right. So now asking the right question, and you'll notice that in one of my earlier charts, I showed that the professional services was the biggest slice of the market, right? And that's the reason why, right? People need a lot of help with that. So that's a huge area now, and you're seeing that. You're seeing all these big data companies. I've actually invested in a predictive analytics startup, where the mantra is data science without the scientists, right? So the idea is that you shouldn't have to invest like in building a big data science team. If you can get 90% of the way there with 10% of the effort, right? That is, just get basic insights really quickly, because a lot of this machinery that people use as analysts can be systematized and packaged into a box and make things simpler for you. And the third question...
One is these two processes are extremely expensive, right? So how do you see it becoming like a commodity?
Well, that's what I'm saying, right? So you're moving towards that, right? Because a lot of this stuff is repetitive, right? So the move is towards efficiency, right? It's towards like maximum insight per unit of effort.
So what you're saying is, as of today, in the near future, we see that the data collection is an expensive process and is...
No, data collection is actually cheap. Data collection, for the most part, is the cheapest part of the process, right? I mean, you can observe everything, right? I was watching some commercial the other day about, the NSA just observes everything, right? And they don't discriminate. If there's something to be observed, they observe it, right? The trouble is you've got so much crap in there, right, that you're observing. Most of that stuff is useless, right? So it's kind of, how do you find that needle in the haystack, right? And that's where machine intelligence comes in, right? So you just observe the hell out of everything, right? And then you have this layer of intelligence that says, all this stuff is garbage, throw it away, it's not worth keeping, but this stuff is interesting, keep it, right? So the data collection part is cheap. It's the analysis that's expensive, right? And what we're moving towards is sort of this new layer of intelligence coming in that's making that cheaper, right? That's the trend towards commercialization.
Susan.
So the problem is, how do you validate a system that's giving you an answer out of all of this massive data? Is it that as the data becomes much more comprehensive, there aren't going to be competing solutions to finding your need with a mistake? I mean, that's a problem that we face all the time, right? You have reams and reams of data that's coming from financial markets.
Right.
And the question is, out of 2 or 3 solutions, apparent solutions to a question, how do you know which is the correct one? How do you get other people to
You
come
mean which
and
one is?
validate?
You mean which one is better?
Yeah, or just get someone else. So you hire a consultant, the consultant analyzes your data for you, and for your answer, for your question, they say this is the answer, and they justify it beautifully.
Right.
How do you validate it if you don't have the ability to judge yourself? Do you hire someone to validate the data or validate the answer? How do you know that your decision-making system is the right one? It's doing its job.
So
It's similar when data was smaller.
right. So that there's 2 ways to look at that question. One is in terms of just from an epistemic standpoint, how do you compare A versus B, right? How do you know that A is better than B, right? And let's assume that we can somehow solve that problem. It's a statistical problem. It's a scientific problem. We can solve that. The more difficult part is in coming up with the A and B, right? How do you really know? So when someone says, oh, we did the analysis and here's the solution, right? The more difficult question there is, well, there could have been other potential solutions. Did you consider them all, right? And in the old days, the consultants knew best, right? And they would tell you, right? Well, we've solved 10 other problems like this, and believe me, right? This is the way we analyze the data, and this is the best. That's become a lot less of the case now, right? That's become much more complicated now because of the explosion in data. And you're right, in a sense, it used to be easier when the data was smaller, right? Now with the large amounts of data, that's become harder, and that's where you need more of the machine intelligence to be, as part of the picture in coming up with what's the A, B, C, D, E that you should be looking at in the first place. Yeah.
Following up on her question, in somewhat broader terms, in terms of the complexity of data, vis-a-vis the uncertainty of the outcomes that you see. When we're talking about the neural network problem, I know Hal White and a whole bunch of others showed that there was some asymptotic equivalence to this class of neural network models versus various classes of nonlinear models. So, I mean, as the data is becoming more and more complex, how is it that these models seem to be able to reduce the level of uncertainty, whereas a priori you'd have thought that uncertainty would have actually increased?
So this is where I really feel that looking at the problem in terms of signal and noise makes a lot of sense, and I don't think people have done enough of that earlier. I think people just said, well, here's a bunch of data, here's a bunch of models and their properties, right? But I think it makes a lot of sense to ask yourself the question, how close is the data to being completely random, right? And because if it's completely random, then you just might as well go with the average, right? Then you're just wasting your time beating your head trying to extract blood from a stone, right? And to me, in my sort of 30 years in this field, I think that's been the most useful practical insight I've gotten, is to look at problems or data in terms of what do I expect the inherent sort of noise or structuredness in this data to be before I start looking at models, right? Because to me that's the most important thing, because it sets your expectations in the right ballpark. Because if the data are noisy, then it almost doesn't matter what method you use, right? But once you get reasons to believe that there's more structure in the data and there's larger amounts of data, right? Then essentially what you can do is you can start looking at models that have less of a bias in them. And by bias, I mean literally that a linear model is a high bias model, a nonlinear model is a low bias model, right? So a linear high bias model will be useless or not as useful as a low bias model if I've got a large amount of data and I have reason to believe that there's signal in the data, right? So as long as I have reason to believe that there's signal in the data, larger amounts of data are better and lower bias models are better, right? I mean, to me, that's a much more useful insight than just saying, well, model A is better than model type, or technique A is better than technique B, right? Which almost is immaterial if there's no structure in the data. Or if there's a lot of structure in the data, it almost doesn't matter what the model is, right? If I've got like a completely deterministic kind of problem, right, then it's not a challenge at all. If I've got a completely random problem, not a challenge at all. It's all of this, it's the continuum in between that's interesting, and where do you lie on that continuum is the interesting question.
So one part of this is the government, say the NSA, for instance.
Yeah.
The other part of it is when private firms begin to use these techniques to dig into patterns. So let's take Palantir as a great example. Now my hypothesis here would be that Palantir does the work it does because it actually can get around the restrictions placed on the government because it's a private firm. I mean, there's a real danger there of privacy invasion, all of that stuff. And when it's in the private sector, which does not have the sort of barriers placed on it the way, so don't spy on Americans.
Yeah.
Now, Palantir is not necessarily subject to those rules.
Right.
Sorry, what is Palantir?
Palantir is is probably the highest value big data company. It's one of Peter Thiel's companies. So, according to popular legend, they were involved in the hunt for Bin Laden. There's a range of things. There was the insider trading. All of this was done using Palantir technology. And today, the last funding round that they were valued at $9 billion. So it's a Peter Thiel company. It's a fascinating company, totally big data. The problem is, are you actually getting these contracts because you're playing in a space where the government cannot play?
Yeah, that's a great question. It's unknown to most of us what the government's actually doing. Right?
Exactly.
Whereas, in a strange sense, the Orwellian scenario hasn't really played out. In the government is not necessarily who's watching you. It's Facebook and Google and Palantir and all these companies, which seems to be perfectly fine with people, right? In fact, when I ask my students, are you concerned about being observed? They say, no, I don't care. There's nothing interesting going on in my life, which, by the way, is not true at all.
Exactly.
Right? But that's the kind of thing. I got nothing to hide. Like, you don't know that until you do have something to hide. Right?
I always joke that we grew up being scared that we were going to end up in 1984, and instead we ended up in Lord of the Flies.
Exactly.
Yeah.
The William Goldman book of horrible children. Okay, I have an economist question. So whenever we economists look at this attempt at ferreting out patterns in data, we have three strikes against it. Okay, So the first is that, oh, this is a mere correlation. There could be many things going on. So
Yeah.
how do you make this actionable, and where does it actually start becoming useful? You know, y equal to a plus bx, x equal to a plus by,
Yeah.
and we just throw our hands up in horror and say, we don't know. You need theory. You need exogenous variation, something. Okay?
Yeah,
So
right.
that's our
Yeah.
concern number one.
Mhm.
Our concern number two is that the world is a messy, complicated, nonlinear system, and it keeps changing. So
Yeah,
you
yeah.
fit the model on the data, and the world went and changed on you.
Right.
And this
Right.
seems to happen all the time.
Yeah.
And the third is the Lucas critique, which is that when people start using the patterns in the data, the system changes.
Yeah, all of which are great questions, right? So let me respond to. So the first one is it reminds me of this Wired article, right, by the chief editor there, saying the end of theory, right? That who the hell needs theory when you've got data,
Yeah.
right? At the end of the day, it's like you can have all the theories you want. If my data are predictive, I don't care, right? And I know it bothers economists, but there are a lot of people who say, you know, sometimes the world is complex and it's sort of beyond the grasp of human beings to formulate sort of simple theories that explain it, whereas if the computer can come up with a model that is predictive and reliable and does a job, I'll use it, right? And I'll worry about building the theory later, right? So that's one response. The second one was...
The world keeps changing.
The world keeps changing, yeah. I completely buy that. And that's one of the reasons that my models keep changing, is that, you know, it's just like at the end of every year, it's like, hey, the world has changed. Like I have a 1 year new data, I shouldn't ignore it, and I certainly shouldn't think that whatever I had in the past would continue to work in the future. Let me just take this data into account and rebuild, right? So that's
or
a
maybe we should
pragmatic.
not be using older information, because
No,
the older
no.
information is coming from a different world. So that's
No,
the concern.
yeah,
What's the
so-
correct window?
Right. So that's a really interesting question, and people ask me this all the time, which is like, how do you decide how much to use? And my response is, I use everything, because it's not necessarily the case that what happened last year is more important than what happened in 1994, right? Because you know, in 1994 the Fed started tightening. Hey, that was a regime that's perfectly valid if the Fed starts tightening again, right? So I shouldn't ignore that just because it happened 20 years ago, right? So older data isn't necessarily less valuable. On the other hand, if I'm doing high frequency trading and I'm looking at like market microstructure, chances are I probably do want to neglect what happened in 1994, because that has nothing to do with the reality of modern day markets. So the answer to the second question is, it depends. The third question is a really fascinating one, and there's no real good answer to that, which is that the very act of using these models changes the world, right? And this is true in sports as well, right? Because if everyone starts believing something to be the case and acting on it, then the effect disappears. And that's just sort of a reality, right? That happens anyway, and there's just no way to get around that, and there's no great answer to that question. I mean, but that's been true, like, you know, all along. You know, it's in basketball, you know, Phil Jackson, who's credited with winning 9 out of 19 titles, came up with this thing called the triangle offense, right? The triangle offense is fascinating. It's an offense where you form equilateral triangles among players, which creates the maximum number of passing lanes and therefore the maximum number of shot opportunities, right? So Phil Triangle basically, is a very scientific principle to basketball, said the moment you pass the ball, move and create a triangle, right? Now, it turns out that this thing is very difficult to train basketball players to do. It's not that easy. The concept is easy, but it's hard to do that. But if everyone starts using the triangle offense, the effect goes away. But that's just reality, right? There's not a whole lot you can do about that. It's always been the case, right? So that's not unique to big data.
Yeah, I'm a completely non-technical person. I've done a bit of AI control and filtering and all that. The 3 points I had were exactly the ones that Ajay just now asked, so I'm encouraged to say a little bit about that. One is, I'm wondering if the whole idea of understanding will change with, or the premise of understanding is entirely, as a theory person, when I talk of understanding and theory, you know, it's the cognition process, it's the computational algorithms, and it's the Gödel's theorem, that's the complexity and all that come to my mind. Is that all passé for a large class of questions? That's one. I'll ask the 3 questions corresponding to what you
So can I answer the one at a time because I lose track? You know, my mind is too simple.
It will be just a revision because
Okay.
it's just 3 of them.
All right, I'll try and keep track.
Otherwise, I'll forget what I have. The second has to do with, does this whole thing then depend crucially on the steady state problem, which we grapple with in economics also?
Yeah.
Which of course then as a variant therefore, in an economy which is varying and changing fundamentally, will this kind of a thing work? And your thing about you know, using some kind of a filter, you used a period, a window of 1 year, you said, and all that is well taken, but that's something that we do even with steady state stuff.
Yeah.
You know, that's basically updating and
Yeah,
so on.
yeah, yeah.
And the third thing is to do with, I mean, I wouldn't rush to look as critic, but basically, is there a first mover advantage here? In which case, don't let it be common knowledge. Because if you put, especially where you're dealing with zero-sum games, if you're beating somebody like that, why should you be commercializing it? Do it yourself and make your gains. Because if everyone does that, then basically do the margins go down? And
Yeah. So
which is actually the same
right.
question.
So the answer to the first one is yes, the world has changed, right? This is, like I said, that we now have a whole new way of observing and learning, right? So it is a whole new world than it was
the
even 5 years
part
ago.
of what I said was for a large class of questions. So, I mean, do you take that, or do you think for everything the concept of understanding has undergone a change?
I think for many things, but yeah, and call it everything, right? I mean, I'm very hesitant to say everything, but for almost everything I see around me, the ways we can observe and learn have changed, right? So fundamentally, the world has changed because our ways of observing have changed. I mean, we didn't have these. Everyone didn't have these things, you know, 10 years ago or 15 years ago, right? So a lot of our ways of observing have changed. Sensors have cropped up all over the world, right? New York City is wired with sensors, right, that are measuring movement, environment, sound, all kinds of stuff, right? So there's a whole new field of urban science that is cropped up, like because that's enabled by new ways of observing. So by and large, yeah, like things have changed, right? Things have completely changed and the ways of observing and learning have changed. The one thing I didn't say is that the role of human creativity has not changed, right? That is, there's a real role involved in being creative on how we look at problems, right? And so when I said earlier that sometimes I may want to look at 20 years of data, sometimes I may want to look at 1 year of data, right? That's a human decision at the end of the day, right? Now, a computer may figure that out on its own, but not for the foreseeable future, right? That's where formulation comes in, and that's where people really need the help. Right? That's not going away in the foreseeable future, right? That's sort of still science fiction-ish. Right? That's not going away. And your third part, there are definitely first mover advantages, and I think that in general, we're seeing more and more of that in most spaces. You know, so a company that moves into a white space, right, that has the first mover advantage, quickly captures that and very difficult to dislodge. So my conjecture is that yeah, there is a first mover advantage.
So in a finance context, does it happen that the method? How long have you been doing this actual operations and trading?
About 20 years.
Okay, so that's the ideal span over which to ask this question. That was it the case that there were things you were doing earlier which would just not work today? They would peter out because everybody knows them. So is that that's the sense I think?
Yes, absolutely.
So, you know, there's stuff out in the university which is cutting edge, and then it becomes standard. We put it into textbooks, and then it becomes useless.
Or regulation changes and it changes the phenomenon, right? So I was talking about, like, I did high frequency trading for a while, and then in the financial markets there's something called Reg NMS that came in that where you had to guarantee someone the best price for an order that came to the market. It completely changed the market structure, right? Reg NMS doesn't exist in Europe, doesn't exist anywhere else in the world. That completely changed what I was doing or what I was exploiting, right? So it can be the case that people copy it, or regulation changes, or there's some sort of a market sort of shift that happens that changes things. Was there another part to the question?
No, that was it.
Yeah.
Was there a couple more questions? I think I saw a
So,
couple.
you know,
hands.
as part of logical corollary of commercialization, how do you see the the government regulating this industry actually? Because that's something I've not seen. The latest one is the Sony hacking. Nobody knew what sort of implications that it had on its customers and how they were protected and things like that actually. And government didn't have a regulation how that has to be protected. And you also indicated some of the examples to what extent it can be outsourced by the private firms and things like that.
Right.
So how do you see this evolving actually? Are there examples of regulations coming into this area of big data collection, right from collection to analysis to solutions and things like that? Because I can use any logic to prove what I want to prove, but end of the day, the logic may be biased logic actually.
I don't have a good answer to the question. This whole issue of regulation is a very messy one, right? I mean, financial markets are probably the most heavily regulated markets on the planet, right? I think the U.S. financial market is incredibly heavily regulated, right? But outside of that, I don't see a lot of regulation, right?
Regulations on the data, actually, how the data is collected.
Well, Ruben was talking about Palantir and all
Right.
these companies. There's no regulation on that. It's Wild West, right?
I mean, Facebook is doing it.
You can
Right,
be
exactly.
you
So-
can be sure that Google, Facebook, etc. know a hell of a lot more about you than you know about yourself, right?
That's what, is the government working on, what data they can use it,
It's
how
very-
they can
it's-
use it, how they can market
No,
it?
no, it's very difficult to come up with with any kind of regulation on that front. Right? It's a free world, right? Other than the fact that companies themselves don't want to take on sort of a risk, a reputational risk, right?
Okay.
That they get hacked or they misuse data or stuff like that, right?
Self-regulation.
Yeah, to that extent, they're motivated to sort of try and strike the right balance between taking that risk that'll get them into trouble versus exploiting the data for commercial advantage, right? That's kind of the line I see companies walking in the commercial space, right? It's very difficult for a regulator who's behind the 8 ball, right, to come in and impose any sensible kind of regulation, right? The SEC right now gets its data on markets from a high-frequency trading operation that invested a lot earlier and more heavily in technology than the regulators did, right? There was a whole bunch of high-frequency trading people who invested in these big data machines that now supply the SEC with that data, right? Because the SEC didn't invest in that, right? The regulators, by and large, tend to be behind the 8 ball for a number of reasons. Plus, they have to be careful. They have to come up with something sensible in a space that's just so rapidly changing and hard to get your head around. It's difficult to come up with any sort of regulation in this space.
Taking a clue from the same thing is now SEC is also talking about big way in various circulars about data governance and all that subject. One of your paper also talks about that. So I think that's the area again. I think government and the regulators are looking in a big way now. From a data governance point of view, and there's a lot of restrictions and a lot of rules and regulations are coming on that area also.
Well, the regulations, like I said, in the financial arena, I can see all kinds of regulations coming into
And the governance part also. Yeah.
Well, the governance part is a little trickier, right? I mean, I can see regulators saying that you can't use customer data to front run them, for example, right? But you can't actually come up with models that are going to predict what the customer is likely to want based on their past patterns and front run them, right? I can see regulation coming around in those kinds of areas. Right? But outside of that, I can't see regulators saying, well, you can't use Twitter data to advertise to people or infringe on their privacy or something like that, right? It's very difficult to
Why would you want
regulate
to do
these.
that? What's the market failure?
Sorry.
Why would you want to regulate that? What's the
Right.
market failure?
Yeah.
Yeah, no, but that's a subject which has been talked about at least from a financial market point of view in a big way, that the data governance part of it. and that's a question why I was trying to ask you initially when I asked that question of geographical jurisdiction. When you ask the right question, is basically when you're talking about governance, you're talking about governance in a particular area itself. But if I take an example, who is doing a data analytics work or a data engineering work or any type of data work sitting outside the jurisdiction and supplying it to that particular country, then the governance doesn't work there. That's the reason why how stringent you can make this governance.
Well, I guess what Ajay is saying is that the market will take care of that in theory, right? Except that in the financial arena where you've got or maybe in other arenas where you basically, the regulators say you can't abuse customer data. And in finance, it's pretty easy to define that.
Yeah.
In other areas, it's less easy to define.
Yeah,
something
it's
like
more
that.
from finance market point of view I was talking about.
Was two questions here.
In your opinion, how well placed are global banks in utilizing big data outside of their trading strategies and stuff?
You mean customer data?
Customer data.
So my view is that, so I did some of this when I was at Morgan Stanley in the earlier days, just looking at transaction data to come up with profiles and make offers and stuff like that. In my view, banks have actually not made huge headway in that area, even after combining it with other kinds of data, because I think they're observing a very limited slice of customer activity. I think a company like Apple has a much better chance of making huge inroads into that space, maybe through Apple Pay, stuff like that, than banks do. Banks, I think,
typically banks have a hell of a lot of data, but it appears that they're not able to really make much sense of it from risk management or product delivery.
well, because they're observing a very limited slice of customer activity, right? There's only so much you can extract from that, right? So there's, you're observing a limited number of people, you're observing a limited number of activity on them. Now, if you're a credit card issuer, you can actually, there's more value to be extracting from that because you're actually observing people's transactions, right? So it depends, but if you're a trading operation, there's probably less scope for extracting value from that kind of data than consumer data. But again, as a whole, I think banks have been pretty limited in what they've been able to do because they're not observing your entire sphere of activity, right? They're observing your pretty limited scope of activity.
Have you done any research with Indian data?
No, nothing to really, nothing I can talk about. Nothing substantial.
So discussing about the offers and everything, right? A lot of tools are available. Even tech startups and all mid-size, they've been able to use data much more than what the traditional firms have been. Because online you can actually track the entire user behavior, and people have been giving offers and everything on real-time basis. E-commerce players have done it really well, but even others are picking it up. The traditional firms haven't wrapped their heads around, that you can actually use it and make it a lot more actionable. So that's been the change. The tech firms, I think, are much far ahead in terms of using their data and putting it into action.
It just comes to your question, I've looked at very limited amounts of Indian market data, and that's essentially been through my students at ISB, where I used to teach a course regularly that I haven't this year. So that's been my only real sliver I've looked at, and there's not a whole lot to talk about there, other than saying that Indian markets still tend to have more inefficiencies in them, but that's hardly surprising. And so there's more opportunity here than in the more liquid, developed markets.
So we'll take two more questions. You guys said.
Yeah, my question is more on the government side. Is the government a big consumer of big data analytics for non-surveillance, non-security purposes? And what kind of questions is the government asking these?
I don't have a good answer to the question. I mean, other than surveillance and taxes, right? So big use in tax, which is not surprising. So it's mostly with the checkbook kind of thing. Right?
Well,
so
it's the same. The
important.
patterns that lead up to a terrorist attack, the patterns that lead up to a tax law violation. It's the same. It's just surveillance.
I suppose. Yeah. That's a reasonable way to look at it.
And you had a question.
So for this data analysis, it will require certain kind of technologies to be used. So, so mainly the programming languages. So, does the selection of this language depend on the type of question one is trying to answer, or are they more industry specific, or it's a combination of both?
Not really. I mean, in my in my sort of, at a very general sense, right, you're seeing more and more of a move towards open source kinds of stuff. Right? So
R
like,
programming.
well, not even R, like Python, for example, right? I mean, the kind of stuff that's available in Python that you can do in, a day that used to take months is just mind-boggling. Right? So and people's expectations are, hey, like I wanted to use a neural net the other day to look at some news data, and I went to Python and I couldn't find one, so I complained to one of my colleagues who's a deep learning kind of guy. I said, what the hell, there's no Python library for a simple backdrop neural net? Because my expectation was that I'd find the latest and greatest and it would be right there. Right? So in the old days, in the days of BI and all of that, those tools tend to be more proprietary. You get Oracle Financials and Microsoft and all of that. With big data, we moved towards Hadoop and more open source kinds of things. So the proprietary aspect is sort of, has become more eroded, and you have people with access to similar kinds of technology. So those kinds of advantages are flattened out, relatively speaking.
Okay, if nobody else is pressing questions, I just want to, since only because nobody else has asked the question, which is everybody from Elon Musk to Stephen Hawking are warning about the singularity moment. I mean, is this something that people like you ever worry about, or are we just, is it just hand waving? I mean, what?
No,
there's just too many people talking about it today.
Yeah. Till a few years ago, I would dismiss it.
Yeah.
Right? And people would say, well, if everyone starts doing what you're doing, will machines be running the world? And I say, no, the world is much more complicated than that, and machines are nowhere near sort of achieving that level of intelligence. Now I've become I appreciate that view, because what I see is like it's frightening, what machines are able to infer about
this
me.
is still not remotely strong AI. This is just, dumb old AI done right. So
well, I don't know what you call it, right? You can call it anything you want. It's just
through
frightening.
into human cognition and creativity, and that's really the strong AI point, that a machine would wake up and compose a poem because it felt like that. It's never going to happen with current technology.
You already have like Twitter accounts that you can't tell whether it's a human or a machine.
I understand.
Right?
Each one of them is programmed to do one specific thing, whereas we wake up and we decide what we want to do.
Well, no, I don't know whether that's really the case, right? A lot of these Twitter accounts, right, that are actually machines, tend to evolve, right? They actually tend to be tweeting about stuff, and now you may argue that, well, they've been programmed to.
They're just an ELIZA. They're a chatbot.
Yeah, I see where you're coming from, but I tend to take this kind of fear a little more seriously than I did a few years ago, where I would dismiss it and say, no, that's not happening. And I don't know, I don't care whether you call it weak AI, strong AI. I'm just concerned at what I'm seeing machines able to infer and do and perhaps do incorrectly or.
So can I just engage you in this question? So for example, people say you have a driverless car and it will now make moral choices such as, do I swerve to the left and kill a child, or do I stay on and I killed an old person? Now, and this is the sort of question that people are thinking about today, and I agree, that's a tough question. Now I want to say, actually that's not so different. Engineering companies have always made moral choices, that do I make the brake lining stronger or weaker? I could save 74 rupees and reduce the number of accidents, or I could have more accidents. So it's not that much of a structural break. I mean, the word moral choice is a freighted term that goes with the whole cosmology surrounding it. Actually, all that's going on is old style engineering in new settings.
Well, but it's that's true. But somehow, when machines are making the decisions, we tend to get more frightened, right? So we're not as frightened when humans make mistakes as when machines make mistakes. Like humans make mistakes, what the hell, we're not perfect, we'll make mistakes. But somehow with machines, things take on a different sort of sense of priorities. You talk about driverless cars. Well, could you have pilotless planes, right? The joke is that the plane of the future people aren't going to have like driverless planes. There'll be a human, there'll be a dog. And the role of the dog is to bite the human every time he tries to do something. Right? So this is kind of because people just feel comfortable. There's a human sitting there. Right? So you can kind of look at the world in so many different ways, and there's no right answers, and we're just confronting these new questions in a different context now. Where we're just much more frightened because humans seem to have a limited capacity for error, at least we believe so, whereas machines tend to have like an infinite capacity for huge blunders, right? And so there's this real fear that there'll be these kind of real outlier things that machines will do when they just kind of go crazy. But I don't have an answer to this question. It's but the short answer to your question is, yeah, I'm concerned too.